Hello and welcome to the second video on the setup of this MicroVector. Now I'm putting the MicroVector in my ZOHD Dart XL to give me all of that fantastic goodness that the Eagletree Vector gives you. But I'm using the MicroVector just because it's a slightly better fit inside the chassis, but using the MicroVector, as I've already talked about in the first video, presents you with a couple of problems. The larger vector has all of the connections that you need, so you just plug everything from your model in, and it's designed to be very much plug and play. You don't really need to reach for the soldering iron at all. The MicroVector is a slightly different proposition, with all of the cables not being made off at all, so you need to be handy and be comfortable with soldering and also crimping as well to put everything together. Now, this is part of the entire Vector series. I'll put a link in the description. So if you're interested in its bigger brother and how you set it up as well, all of that is already done. I'm really focusing here on the differences for the MicroVector, but I'm still going to cover the entire setup if you're just trying to do it by watching these videos. But I'd heartily recommend go and watch the whole Vector series because it explains everything and also gives quite a lot of tips and tricks about how you set them up. And those tips and tricks are relevant for not only the full-size Vector, but for this MicroVector as well. So in the first video for the MicroVector, we had a look at what it was, how it worked, and we set up two of the main connections. We're going to work our way around and do each of the connections in turn. We set up the receiver. We did that for S-Bus using the +5 volts ground and aileron input, and that all worked beautifully. And we've also wired together the power cable. Again, no JST plugs like there is for the big Vector with this. You actually have to decide what voltages you want and solder those together. So that has all been done, and I've installed the power cable into the back of the model in line with the power coming from the battery to the ESC. That's going to monitor the current and let me know how much capacity and voltage I've got left in the pack. And it's also going to provide the power to power the MicroVector itself and the 12 or 5 volts. I'm powering both of my bits with 12 volts for the FPV kit too. So the next job we need to do on this one is to sort out how we're going to connect this MicroVector up to the servos and ESCs that are already in the model. Now those are using normal servo plugs and there's no servo pins or plugs on here to be seen. So this is something that we're going to have to set up. Now I would recommend for a plane that you set it up like this. What I've got is a little row of 4 3-pin servo pins. So this is what the servos can plug into, and I'm just going to make off all the cables at the back. Now looking at the chart in the manual, you can see which is which, and we're going to have to connect the elevator, the aileron, throttle, and potentially the rudder if we had a rudder as well. I'm going to add it into this kit in case I ever move it along. It means I don't have to make it off again, so I could get away with a row of 3. So what we're going to do is I'm going to connect all of the middle pins in the row to the +5 volt line, solder all of those together, and then I'm going to connect the ground line to the lower set of pins and then make off the top set of pins for each of the signals out. So the throttle, elevator, aileron and rudder. I'm just going to keep a track of which is which so I have a rough idea where I'm going to plug everything in. You don't want to be plugging a throttle into the servo output and vice versa. So cover that in a bit of heat shrink for protection. I'm using clear heat shrink so I can clearly see which side is the negative for when I plug all the servo leads in, and then it's just going to be a case of plugging those servo leads into the relevant output when we get to the plane. Next piece then is the FPV harness. This is the last bit of modification we're going to have to do. So because we've wired up the 12 volt lines for this from the power brick, each of the outputs is going to give me 12 volts of ground, and we've got a video in and a video out. So we just need to make these off. Now I'm going to make mine off with servo connectors. I'm going to extend the camera. And again, this is something as you go through, it's worthwhile just test fitting everything so that you're not making these cables too long or leaving yourself with not quite enough room. I'm going to fit an extension to go to the front. I'm going to be using one of these Mars SV2 cameras. It's something that I've got in to try. The original Mars camera was very nice, and this new version 2 looks even better. So this is a great way to test it out. So this is going in the front. So that's going to need an extension cable. So that will be soldered onto the end. And on the other side, I'm going to use this FXT video transmitter for the initial test and setup. Now that's going to fit into the underside of the canopy in a lot of airflow. Hopefully that's going to keep that nice and cool. And I'm going to make off the end with the servo connector and wire the other side of the servo cable into that video transmitter. And the reason for that is that I am planning to swap some of the pieces around in here, change the receiver to something like a Crossfire, and potentially put the 2.4 gig FPV stuff in here. So I want them to be able to be unplugged. So now we've got those cables all together, the next job is to start wiring everything up. Now we have to be aware, of course, that once the model goes into the plane, we cannot access the USB unless we've got a very, very tight right angled cable. There isn't a ton of room in here. So what I'm going to do is quickly plug it back into the PC and set my modes up. I'm going to set a stabilizer off, or what I'm occasionally going to refer to as manual mode in this. We're going to need that for the first test. I'm also going to select 2D mode. So that's going to be needed for the trimming. And I'm going to have a return to home as well as kind of an emergency oh dear switch. Do that before you plug it in. Again, all of this can be set via the on-screen display, but it's just easier to do it here before we plug it in, because once it's in, it's going to be bloody tricky to wire it up to the computer. It's a shame the USB cable access port isn't on the top or somewhere else. And I'm looking around at the moment for some kind of adapter that'll let me get the USB cable back in once it's in the plane. Installing it into the plane is relatively straightforward. It's just making all these ends off, and hopefully as we've gone through, the lengths are right. So it's just a case of using double-sided tape, sticking it in place and making sure everything is nice and neat. The only thing I did spot was once I'd very carefully placed my compass and magnetometer on the little bridge piece that's in between the two canopies that cover the electronics at the back and the battery and camera at the front, I realized that the compass in there was potentially going to be interfered with by the big neodymium magnets that's holding the battery hatch closed. So my only choice here really, because I already cut the foam and positioned the GPS and compass, was to remove those magnets from both the foam on the plane and the foam in the canopy, and design and 3D print a catch that's going to keep that canopy in place. Because it's plastic, it isn't going to interfere with the compass. We want the GPS and compass as far away from the high power as we possibly can, and as far away from stray electromagnetic fields, and definitely as far away as we can from magnets. So that was a bit of a mistake on my part. I should have thought about that before I stuck the compass in place. So here are a few close-up images of how I've installed everything into the ZOHD Dart XL. It fits really nicely. We've got the cameras up in the front, that Mars Pro V2. We've got the GPS mag on the top, now away from magnets luckily, and we can actually do the test. Now when you first plug it in, it might ask you to confirm the settings for your frame type. And by going through and doing stuff on the computer first, it means that all of the controls on the radio are going to work. They might not be right for the plane, and that's what we're about to test. So here we are powered up on the bench. I'll insert the image in the bottom right hand corner. So I've got the view from the camera. So the FPV stuff's all working. I'm in really good shape. So I'm going to waggle the sticks on the radio and let's see if the controls are backwards or the right way around. So the aileron is backwards and the elevator looks okay. So yeah, elevator is fine. That's working properly. The aileron is the wrong way around. That's reversed. Now this is entirely expected. It's not a worry at all. So what I'm going to do is I'm going to go into the radio and I'm going to reverse the aileron channel. Now that means that the settings to go through the on-screen display in the Vector are going to be backwards at that point. But once I've got all that set, then I can go through and I can actually do the radio calibration again just by accessing the menu in the on-screen display. Now the other thing I'm going to do here is, because I kind of took a note of where the control surfaces needed to be in order for the craft to fly straight and level, I'm actually just going to use the trims on the radio to put the control surfaces back to more or less where they were. I'm just eyeballing this. It'll just help me when we come to the next video when I actually do my manual trimming. It'll be an awful lot closer. And all of these midpoints for the channels are also going to be saved into the Vector when we go through the radio calibration again. So now I'm happy that that's all going to work. I'm going to flick the mode switch and keep flicking it until the on-screen display appears. I'll insert the OSD here in the bottom right hand corner and we're going to go through all the settings. And again, everything that you can do with the Vector is available through the on-screen display. It's absolutely brilliant. So I'm going to go down here and select the radio calibration and start the process. and it's going to walk me through in a very similar way to the way that we did it on the PC, all the different settings. It's going to ask me to move individual positions. First of all, it's going to do the fail-safe stuff, and then when it comes back up, it's going to ask me to move the radio to the different positions, and it's going to record each of those. It's also recording the middle channel positions as well, and all the trims that I've set on the radio that I've just done it to get the control surfaces back is all going to be saved as well, which makes it super easy. And this is one of the really cool things about the Vector. It's so easy to set up like this. So I'm just going to walk through the entire thing and just keep toggling that mode switch, moving everything into position, and once everything is saved, I am going to be happy. Now, the other thing I'd probably recommend that you do here is, once this is all done, is also calibrate the level. We'll do that again in the next video, but I've got a reasonable idea of the attitude of the craft. It's just going to reboot now while it's saved all of those pieces, and when it comes back, let me just wiggle the sticks. Hey! There we go, and they're settling in the right position as well. So elevator and aileron are all working the right way around. We are set, and it's that easy. So if I flick the switch, you can see me going into 2D mode and everything else, and we're set. The last thing to do here on the bench before we move on is to make sure that all the correction from the Vector is working properly. So pop it into 2D mode and rock it side to side and put the nose up and down, and you're watching for the control surfaces to move to correct that uncommanded movement. As usual with the Vector setups, once you've got the radio calibration all done properly, then this should pretty much always work. If it doesn't, then just rerun the radio calibration and follow the steps that we've already gone through. In the next video, what we're going to do is first of all fly in manual or stabilization off mode, and we're going to get those trims absolutely perfect. Once we've done that, we'll land, and then we will pop into 2D mode, not 2DH, just 2D mode. We'll fly around, and then once it is flying nice and level, I might need to kind of hold the elevator a little bit just to get it so it's maintaining its altitude. I flick the mode switch once, and then I flick it another 4 times, and that will save that new level position for that slightly nose up attitude that we need to maintain altitude. And at that point, then we are pretty much going to be ready for return to home. So join me in the next video where we'll finish the setup of this Vector, and then it's going to be time for an awful lot more fun. If you found that video useful or like the content, then please hit the like and subscribe button down below. If you want to go the extra step, you can become a Patreon of the Painless 360 channel and help provide support for what I do here. All the videos created here are put into playlists, so if you're interested in a particular topic, have a look at the playlist, and they all are organised in there to make them easier to use. If you're not sure if there's a video for your particular problem or topic you want to know more about, then add Painless 360 to the Google search term that you're interested in, and that should find the video, article or content about the particular thing that you're interested in having a look at.